This is the fourth in a series of videos on confidence interval and means. And to review real quickly, then what we've been doing is we've been finding confidence intervals of a k degree of confidence, and that's equal to x bar plus or minus zk times sigma over square root of n. That's our basic formula, except when sigma is unknown. And if sigma is unknown, we use confidence interval k% is equal to x bar plus or minus t k comma n minus 1. This is the t distribution. We use the t distribution instead of the z distribution because we don't know sigma, so we're going to use sigma hat over square root of n. And this is the confidence level, and this is called the degrees of freedom, and that's the sample size minus 1. And this sigma hat is our sample estimate of the population standard deviation. And the only thing I want you to point out and tell you be careful is just some books, instead of using sigma hat, uses S sub x. That's a real common notation. And S sub x is exactly the same as sigma hat. These are just two different ways of writing the same thing. So what I want to talk about today is this sigma hat, or S of x, how to calculate it. Almost always in problems like this, they go ahead and show you, give that to you, but sometimes you calculate it. So let's go through this. Well, sigma, the standard deviation is defined as this. You take xi minus x bar and you square it and you divide it by the sample size and take the square root. The only difference with sigma hat is what you divide by. And instead of divided by n, you divide by n minus 1. Again, the reason you're doing that is because you're taking, here you're using the population, and here you're using a sample. And because you're using a sample, you're less sure, and the way we see less sure is we're dividing by a smaller number, which means we get a bigger number. So this is the formula we're going to use right here. And sometimes you calculate that by hand, but usually not. Usually you use a calculator. So let me show you how to do that with a calculator. So let's find sigma hat for the sample. And let's do the sample. Let's say we get 12, 15, 19, 13, 18, 24, 26, 12. So let's just use our calculator here. I'm going to zoom in just a little bit. So what you're going to do here, and this is, if you're not following this, this is a perfect thing to just do Google. The first thing you do is you want to go to stat here. So you go to stat and you push enter, and that gives you a list. And what you're going to do, I'm going to clear all this, and then you just type the numbers in. And I just type in 12, enter, 15, enter, 19, enter, 13, enter, 18, enter. And when I'm done, I'll just hit quit. So second mode, second quit, okay? So that's how you get the data in, and it's in L1. So now you're going to do is, you have a button called stat here, and you're going to push stat and calc, and it says one variable stat. So I'm going to push enter there. And now what I'm going to do is I'm going to do one variable stats for the column that I'm interested in, which is L1, and that's under the 1, but it's a second. So it's second L1, and hit enter. And I get all kinds of different variables, and I'm going to look at the one that's SX, and I get 5.39 if I round it 7. Now there's also one that goes sigma x, and that is 5.048, and it's worthwhile to figure out what that means. This is for the sample, and this is for the population. So the basic idea here is that if it's a sample, you're going to divide by n minus 1, and if it's a population, you're going to divide by n. So that's the reason you get the different numbers. But in this case, this is what we want right here. let's say we wanted to do that by hand. You generally wouldn't want to do that, but you do want to know how to do that. And you'll have to do that on an AP test. You'll have to calculate probably once by hand. The first thing you want to do is you want to find the mean. And I'm just going to add those numbers up and divide. So it's 12 plus 15 plus 19 plus 13 plus 18 plus 24 plus 26 plus 12. 139 is 1, 2, 3, 4, 5, 6, 7, 8. I'm going to divide by 8. So my X bar is 17.375. Let's say 17.4. Now the easiest way to do this is I'm going to write the formula over here. I'm going to have sigma hat is equal to xi minus x bar squared over n minus 1 square root. And I'm just going to go type in xi minus x bar xi minus x bar squared. And I'll just type in, put in 12, 15, 19, 13, 18, etc. 12 minus, here I'm going to subtract 17.4. So that's a minus 5.4. 15 minus 17.4 is a minus 2.4. 19 minus 7.4 is a 1.6. And then I'm just going to square all those numbers. Negative 5.4 squared minus 29.16. Negative 2.4 squared is 5. Actually, since you square into these will be positives, your calculator had to be careful with your calculator. 5.76. 1.6 squared, 2.56. I'm going to continue doing that for all of these numbers. And once I do all these numbers, I'm going to add all these up. I'm going to get the sum, add up. I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8. So that I'm going to divide by 8 minus 1 and take the square root. And that's how you do it. Obviously, doing it by hand is a pretty tedious calculation. There's a previous video that will go through it in more detail. You need to be able to do it, but almost always you use a calculator. And that's confidence interval for means part 4.